Hi, welcome to the first part of the pm4py demo that is related to log importing and exporting. First, we try to import access log, that is one of the standard formats in the process mining world. In order to do so, we import the factory method related to access importing, and we use the factory method in order to import this log that contains 6 cases and 42 events. If we print the type of this log object, we see that this is an event log. This means that each event belongs to a case, and the log itself is already organized in cases. If we want to print a trace attribute, we can do it in the following way. Each case in the log can be accessed by its index in the log, and the attributes of this case could be accessed through the keyword attributes of the case. So if we take the log object and we take the 0 index and we see the value of the concept name attribute in this case, we see that the value is free. That means that the case ID of the first case of this log is equal to 3. Accessing the event attribute values is equally easy. So we can access a particular case providing its index inside the log object, and we can access the event in position 0 of the case. That means the event of the first event of the case, providing another 0 to the resulting object. So with log 0, 0, we access the first event of the first case in the log. And through the concept name attribute, we access the activity of this event, that is register request. All the traces of this log starts with register request. The code I am going to execute now simply iterates over all the cases of the log and over all the events of the log, printing clearly the indexes and the value of the case ID and of the activity related to the event. So we see that the command has been successful, and we see its case along with its activities. A log object could also be exported to pm4py through the following instructions. First, the access export factory is loaded and then applied to the log object, providing the path to the output log. So in that case, we save in the current folder an access file named exported log.access. In pm4py, we provide support also for CSV logs. To import a CSV log, we need to load its factory method. So with this row, we load the factory method that imports the CSV. And then we can import the CSV into a stream of events. That means that if we print the type of this object, we see that this is not an event log, but this is an event stream. If we want to look inside the event stream, we see that the events here are not organized in cases, but this is simply a collection of all the events in the CSV log. To convert this format of log into a classic event log, we provide some conversion utilities that could be applied always through factory methods. So we import the factory related to the log conversion, and we apply the log conversion to the event stream in order to retrieve the event log. Then if we print the type of log, we see that this is an event log. Hello, welcome to the second part of this demo that is related to process discovery using the alpha and the inductive miner algorithm. In order to apply such discovery algorithm, we need to load a log file in Access format. After the Access file is loaded, we can apply a discovery algorithm. For example, the alpha miner. To apply the alpha miner, we need to import its corresponding factory method. And after that, we can apply the factory method to the log in order to retrieve an accepting pattern. That means a net along with an initial and a final marking. If we need to see the type of net, we see that this is a pattern. But we can print also the values of the initial marking, where we see that the initial marking has one token in the start place, and of the final marking, where we see that the final marking has one token in the end place. It is possible in pm4py to visualize the process model. This is done by a visualization factory related to pattern. With these commands, first we load the factory method related to pattern visualization, and after that we create the graph with object related to the pattern along with its initial and final marking. When we execute this command, the dot object is ready. To visualize the dot object, we simply need to use this instruction. And then we see that the pattern along with its initial marking, that is green, and the final marking, that is orange, is shown into the screen. We see that all the cases of this log starts with register request, and this is detected perfectly by the alpha miner algorithm. And the cases of the log may end with pay compensation or reject request. We see that this pattern contains only visible transitions, and choose is different from models like the ones that are extracted by the inductive miner that contains also invisible transition. In order to perform a visualization of the performance perspective of this log on the model, we can always apply the visualization factory, but providing in this case requiring another variant of the visualization, that is the performance variant, and providing to the visualization also the log in a way that a replay operation could be applied in order to get the performance on the arcs of this pattern. And if we apply this visualization and view the result, we see that the petinet that was without any decoration has been decorated with performance values on the arcs. The performance values have been written on the arcs connecting the places to the transitions. So, for example, the time interlapsed between the place connected to examine casually is always. Hello, welcome to the third part of the pm4py demo that is related to conformance checking using the alignments and the token-based replayer provided by pm4py. In order to apply conformance checking, we need a process model and an event log. In order to retrieve such object, we need to load an event log from the system. In this case, we load the running sample log, and we need to calculate a process model on top of this log. For example, applying the inductive miner. After that, we can apply the alignments. To apply the alignments, we need to import the alignments factory and then apply the alignments factory taking as parameters the log, the petinet, the initial marking, and the final marking. The result is a list that for each case contains its alignment. If we print the alignments, we see how this object is structured. For each trace, we have a dictionary that contains the alignments for the given case, the cost of the alignment, that in this case we see that the cost is 6 because in the default cost function of the alignments a cost equal to 1 was associated to invisible transition that needs to be traversed in this model. And we see some technical parameters of the alignments and the fitness value of this case that is equal to 1. If we look deeper to the alignment itself, we see that the output is a list of couples, where on the left side we have the log, so this is an activity happen in the case, and on the right side we have the model, so this is a transition that happen in the model. So we see that in the alignment of this case, first the register request transition was fired, then an invisible transition was fired, then the examine casually transition was fired. In order to have a complete view on the fitness of this log and model, we can apply an evaluation factory. First, we need to load the replay fitness factory that is useful to evaluate the fitness between a log and a model. But in this case, we have already performed the alignments, so we can retrieve the log fitness by simply providing to the fitness the alignment content and specifying that we are using the alignments. In this case, if we print the result, we see that the fitness of this log is 1, and the percentage of fit cases is 100%. So we have absolutely no fitness issues in this log, as we have loaded a log and we have calculated a process model using the inductive miner, so we have obtained a model with perfect replay fitness. Now we see how the token-based replay works. Token-based replay is good in working with bigger logs as it does not suffer the performance limitation of the alignments approach. So we can import a log and calculate, in this case, a process model that is not perfectly fit according to the log. In order to do so, we can fit the log keeping only the most frequent behavior. So we apply the auto filter on the log in order to retrieve a filtered version of the log. The filtered version of the log is smaller than the original log. We see that indeed it contains only 872 cases in contrast with the 1400 cases of the original log. Then we apply the inductive reminder on the filtered log in order to retrieve a model that is perfectly fit according to this filtered version of the log, but may not be fit according to the original log. And if we apply the token-based replay, and to apply the token-based replay we need to load the factory of the token-based replay and apply the factory in order to retrieve a list that contains the output of the token-based replay for the single case. If we print this object replayed traces, we see that we have some issues related to fitness. So we see that some cases are not fit according to this process model, since trace is fit is false, and we see that also the fitness value of the trace according to the token-based replay formula is relatively low. This is for the output of the token-based replay on the global side. So that means that we have retrieved a sort of a list of transitions for each case of the log that are enabled by the token-based replay in the model. But the token-based replay permits to obtain some additional diagnostics on the places and the transitions during the replay. So if we execute the replay, providing as parameters the enabling of place and transition fitness as true, we can get not only the list of transitions enabled as output of the token-based replay, but also additional information about the place fitness, the transition fitness, and some activities that are in the log but not in the process model, and so contribute to the unfitness of the log according to the model. To this diagnostic object, we can apply some further diagnostic method. For example, the duration diagnostics helps us to understand if the deviations has caused some delay in the execution of the process model. So, for example, executing this code permits to understand that when the specific transition is executed in an unfit way according to the process model, we see that if we compare the execution time of the fit traces and of the underfed traces, we see that the execution time of underfit traces is much higher than the one of fit traces. Hello, welcome to the last part of the pm4py demo that is about the pm4py website and the community. The pm4py website is taught for users to help them in the installation of pm4py and in the usage of pm4py. pm4py is provided as Python package that requires some dependencies that are available in the most common operating systems like Windows, Linux, and Mac OS X. If a user needs to install pm4py on a specific operating system, all he needs to do is to go to the specific page supporting its operating system and following strictly the instructions that are here. The documentation part provides a large set of examples that the users could apply in order to understand the concept, in order to understand how to use pm4py for its purposes, and is focused on providing support for process discovery, performance checking, filtering, enhancement, case management, social network analysis, and some additional features that are available as beta, like the heuristics miner, a trace clustering algorithm, an algorithm to detect the concept drift in a process in an event log, some utilities to manage BPMN 2.0 importing, exporting, and visualization, and some prediction utilities. The website contains also some contribution guidelines that the developers should follow in order to contribute to the pm4py project. The pm4py project is available as a repository in GitHub and is available at this address. When the user reaches this address, can see the code, can see a link to clone the Git repository, and can see all the releases that have happened in the pm4py library, and can download the releases, or you can see the issues that are in the project. So if there is some problem, you can signal the problem to us, and this helps also in keeping the code and the project quality high. And moreover, you could see some insights about the traffic on the GitHub repository and could retrieve a Docker image containing pm4py by typing this command. A Docker image contains in a clean environment all the dependencies and the latest pm4py version in order to provide the users an easy way to install and use pm4py without changing their local installation. Unfortunately, Docker is available for Linux and Mac OS X platform.